Hey everybody, this is Mr. Beckstrom, and today I wanted to talk about a problem that you're going to see on the project number 2. I'm just going to kind of give you an example of how I would go about working one of these. Now the questions on the project can be a little bit different, but I just kind of want to give you the main idea of what you want to look for. So they're going to give you some type of graph that looks like this. It should have some x-intercepts, possibly y-intercepts on it, as well as vertical asymptote and or horizontal asymptote. So our job here is to kind of identify everything and then try to find an equation that fits this graph as best we can. So let's kind of start with this vertical asymptote, this blue line here. It's not actually part of the graph. It's just it's a line that our graph is going to approach from both sides. As x gets closer and closer to that x value, our y values on the right are going to go towards negative infinity, and our y values on the left are going to go towards positive infinity. And so we're going to have a vertical asymptote, let me write that in, a v asymptote at, looks like x is equal to 4. That's counts by 2s until you get to 10. So let me retry that 4 there. X equals 4. And that means that we're going to have a factor of x minus 4. And that factor has to be in our denominator because that's how we find our vertical asymptotes in rational functions. So far, I'm going to kind of write it off to the right side like this. I think I'm going to get an x minus 4 down here. I don't see any other vertical asymptotes, so I'm going to go ahead and put that in there. Now, in order to find the top of this, what we're going to do is we're going to try to find the x-intercepts. And in this case, it looks like we have one here at x equal 2. So look for x-intercepts. And we have one at x is equal to, negative 2. And that means that we're going to have a factor of x plus 2 in the numerator. But what we have to notice is that this comes down, it touches the x-axis at negative 2, but then it goes back up. And that means as far as multiplicity, we have an even multiplicity. Whenever we come down to the x-axis and we go up, we have an even multiplicity, which means that we have to put that factor to an even power, either 2, 4, 6, 8, 10. And I'm going to go ahead and start with the smallest even power, which is 2. I'm going to go ahead and put that up here in my numerator with a power of 2. And at this point, I kind of want to check my map or my graph to see how I'm looking. So I'm going to pull up my graph here. And I am going to go to y equals. And on the top, we have an x plus 2 quantity squared. And this is going to be divided by, on the bottom, an x minus 4. And hit enter. And if I go to zoom, we'll start with the zoom standard, see how that looks. And it looks like we can see one part of it here, so let's zoom out a little bit. I'm going to kind of center that a little bit up here, maybe about there. And we can actually see that it looks like a kind of a similar graph, except it's upside down. It's reflected across the x-axis. And if we remember to reflect something across the x-axis, we just multiply by a negative. So I'm going to go back to my actual function, and I'm going to hit second insert. I'm going to put a little negative there and see what that does to my graph. And sure enough, it looks pretty similar at this point. So let's go ahead and put in a, well, we can't really do the vertical asymptote there, but what we can do is we can do a zoom box and try to get pretty close to that X and Y intercept there to see if it kind of matches up with what we have. So you start with one corner of the box and then you go up or down and then left or right until you get the other. And sure enough, it looks like the x-intercept is -2. The same thing over here. And it looks like the y-intercept here is 1, which that looks like 1 as well. Let's see if we can kind of zoom in on this. Right, remember this is 2 because it counts by 2, so that looks like it's 1 as well. So I'm going to say that this function here, the one that I wrote out, fits it very well. Let me go ahead and close this out. And so y equals, put a little negative out front, and here is my function of best fit. And what I'm trying to do is just get the general shape, make sure I got the x-intercepts, the y-intercepts, the vertical asymptotes, horizontal asymptotes, everything looking correct, and yeah, it doesn't look too bad. All right, that's it. If you have any questions, make sure to let me know, and I hope you have a great rest of your week. Thanks.